Now, this is Intro to Proofs, and we're going to do progress check 3.7. Now, I'll remind you that this would be the most helpful to you if you actually attempt this first. And the harder you kind of try beforehand, the more you'll get out of this video. Now, we've given a statement for number 1 here. For all real numbers a and b, if a is not equal to 0 and b is not equal to 0, then ab is not equal to 0. And we're asked to find the contrapositive. So, contrapositive, if you think about this statement is P, that statement is Q, and then this statement would be R. This statement is kind of, it has a for all thing going on, but then it has P and Q implies R. So the contrapositive would be negate the conclusion implies the negation of the hypothesis. Okay. And however, it's good to use De Morgan's law to simplify. So negation of the conclusion implies not P or not Q. How do we write that in English? For all real numbers a and b, if AB is equal to 0, so negation, then negation that, then A equals 0 or B equals 0. Okay, so that's contrapositive. Then for part 2, we're reminded of this logical equivalence. The logical equivalence is that P implies, now these are going to be different P's, Q's, and R's now. So forget about the assignment I just gave. So P implies Q or R is equivalent to P and not Q implies R. So that was theorem 2.9 on page 43. It's good to remember in this class what we've covered. It's very good to remember what we've covered. That's a great way to work smarter, not harder, is to not have to redo things we've already talked about. So in this case, remembering that theorem 2.9 on page 43 tells us this, lets us say, so let's do that. So instead of saying here, now P is this, and Q is that, and R is that, and so then I could say, can you see that? Right, it's for all real numbers a and b, if AB equals 0 and not Q, A is not equal to 0, then B equals 0. Okay? Now, why did we go through all those logical gymnastics to do that? Well, because the first statement is hard to prove. It's hard to prove things for not equal to. It's much better to prove things with equal to. So that's kind of why we do the contrapositive. The negation is easier to deal with than the original statement. But then, when you do the contrapositive, you've got this problem where your hypothesis is very weak, that AB equals 0. Then you've got to prove two things, A equals 0 or B equals 0. And so an easier way, it's always easier when you have more things in your hypothesis and less things in your conclusion. That makes your proof shorter and easier. And so using this is why we're teaching logic at the beginning of an Intro to Proofs course. It's because we're trying to give you techniques that will make your job easier later on. So here, we change it so that if AB is equal to 0 and A is not equal to 0, then B equals 0. And so I'm not going to do the whole proof here, but then if you assume both of these things, if A is not equal to 0, you can divide by it. So then divide both these sides by A, and you get B equals 0. That really is the heart, the algebra part of the proof. So that's how logic makes you have a much easier proof.